Hello, pre-cal classes. This is Mr. McAllen, and we are on day 6 of Unit 5. And today we're going to work on using the trigonometry that we started with last week to solve right triangles. So first thing we need to do quickly is talk about if I tell you you have triangle A, B, C, there's a proper way to name this triangle. Capital letters mean vertices for the figure. So I would label this to be A, this to be B, and this to be C, all capital. And as a result, the opposing sides are all lowercase. So the hypotenuse would be lowercase c. The side adjacent to A or opposite from B would be lowercase b, and over here would be side A. So what I want you to do real quick, I want you to pause the video. Well, first, imagine I give you triangle DEF. I'd like you to draw a triangle DEF, and I want you to show me where the sides would go if this was D and this was E and this was F. Could you show me where those sides would go? Take 30 seconds. Okay, well, I'm back, and here's the answer. So you should see that side D is opposite angle D. Side F is noted with lowercase, is opposite angle F, which in this case is a right angle. And side E is opposite its angle, capital E. So let's move on. What are we going to do today? We're going to use trigonometry to solve right triangles. So being that we said the right triangles, we know one angle for sure we'll always have is the right angle. We know one angle is going to be 90, and we have two scenarios. The first scenario is that they give us in the given information one known side and one acute angle. That would be something like if they tell you that angle A is equal to 30 degrees and side B is equal to 5. In the other scenario, they give us no angle, but they give us two sides. Oops, and we'll see that case at the end of the video. And so let's just take a look at our first example here. They've drawn the picture for us. Notice it's triangle ABC, and they've given us the hypotenuse, and they've given us an angle. And they expect us to find all the other features of the triangle. Remember, a triangle has 6 features. It has 3 angles and has 3 sides. And because we know trigonometry, SOHCAHTOA, we can solve for the missing parts of the triangle, as long as we're either given an angle and a side, or we're given, as in case 2, 2 sides. So here we go. Let's say that we want to solve first for the missing angle. The missing angle is easy based on geometry principles. All 3 angles should add up to, you got it, 180 degrees. So that's not really using trigonometry, it's basically using geometry. We should find that angle B is equal to 180 minus 90 from angle C minus the 61.7 degrees from angle A. Using your calculator, make sure you're in degrees. You would do 180 minus 90 minus 61.7. And that would give us 28.3 degrees. So we've got all 3 angles. Now we've got to find our missing 2 sides, and then we could say that we have solved the triangle. So let's solve for side A first. This is where we put our use of trigonometry in motion. For instance, side A is, we're going to use the given angle, 61.7, and we're going to use a hypotenuse. So what is the relationship between side A, 106.2, and the angle 61.7? Well, this is the opposite. This is the hypotenuse, and you should remember that. So for sine of an angle is equal to the opposite over the hypotenuse. This is how we're going to solve this triangle. we're going to solve for side A. So we're going to use angle A. We're going to type in the sine of 61.7 degrees is equal to my missing side A over 106.2. I get my calculator, or I can, if you look at the math, I'm going to cross multiply, solve for A. A is equal to 106.7 times the sine of 61.7 degrees. When I type that into the calculator, my answer is for A, 93.95. I'm rounding to the two decimal places. So now let's go and find side B. I'm going to clean up my drawing, and I'm going to use, it's important to remember this, I'm going to use the given information. My angle, my side, the hypotenuse, and now the adjacent. Hopefully, you could see that the trig ratio that deals with side B, the hypotenuse, and the angle, that would be the cosine ratio, because the cosine of angle A is going to be the adjacent side B over 106.2. So cosine of 61.7 equals B over 106.2. We're going to cross multiply before we even touch a calculator. And when we use a calculator, we're going to find that that value is, let's move the calculator over here. And I get for the side B, 50.34. Now we want to check this answer out. So we have 50.34. What is a way that we can check to see if three sides form a right triangle? Well, this is a simple check. We're going to use Pythagorean theorem. So if 93.95 squared plus 50.34 squared equals my hypotenuse, which is 106.2 squared, then you can say that we found the correct sides, or our sides work for the right triangle that we were given. So you do that on your own, and you should see or verify that they do equal. The next type of problem, looking at the time, the next type of problem is when they give us, as in this picture, they give us two sides in a right triangle. They did not give us any acute angles. So I'm going to draw the picture. The first thing we would do is find the missing side using Pythagorean theorem. So I'm going to pause the video, and when you're done, when you're done, play the video. When you're done solving for D yourself, play the video, and let's see if our answers match. Okay, folks, I'm back, and I used Pythagorean theorem. I found the missing side is either equal to 6 root 10 if you want the exact value, or 18.973. So I'm going to write here 6 root 10. But if you're using decimal answers, 18.973 would be fine if you were going to go to 3 decimal place accuracy. Now, let's draw the triangle over again so we can see it on this side. We have 13. This is angle E, the right angle. F is the small acute angle here. And D is the other angle. So we want to solve and find angle D. So we're going to put the given, again, this is key, and I'm going to talk to you about this in class. We always want to use the given information. The 13 and the 23 were given. 6 root 10 was what we calculated. We don't want to use that in the next step, because if it's incorrect, it will make all of our other answers incorrect. So let's look and try to find angle F. Now, angle F is related to these two sides in what trigonometric way? Well, 13 is opposite and 23 is a hypotenuse. So opposite and hypotenuse use the sine ratio. So you write out the sine ratio of angle F is equal to 13 over 23. Now remember the other day when we were looking for angle F, all we had to do was use inverse trig on that trig ratio and we would get the missing angle. So using the calculator, now that we have the equation written down, I'm going to use the inverse trig ratio of 13 over 23, and that would give us 34.42 degrees. Same ratio or same ideas can be used to find the other angle. So we're looking for angle D. Now, angle D, in this case, 23 is still a hypotenuse. It will always be the hypotenuse, but the 13 side, in this case, because we switched angles, is now adjacent to angle D. So this would be the cosine ratio. So the cosine of angle F is equal to 13 over 23. And again, we use inverse trig, inverse cosine of 13 over 23. In our calculator, I'm just going to use a calculator, find the inverse cosine. 13 divided by 23. And my calculator tells me 55.58 degrees. Now, if you are going to check your answer, which I suggest you do, you should make sure that our three angles add up to, because it's a triangle, 108 degrees. So we have angle F is 55.58, and I'm sorry, this was angle E, my bad. That was my bad, that was angle, let me go back and just re-explain. Angle D has the adjacent side 13, the hypotenuse of 23. So angle D is the inverse cosine of 13 over 23. Angle D is 55.58. So this is 55.58. Angle F is 34.42. When you add them all together, you should get 108 degrees, which we do. So hopefully this video has been helpful. I apologize for angle D. I got ahead of myself. I called that angle F. Just kind of following the same form that I had before. But remember, I switched the angle. My angle was, for the second calculation, was angle D. So I still use side 13 and side 23, which would be the adjacent over the hypotenuse. And hopefully this video helps you understand what we have to do with finding or solving for a right triangle. What I'd like you to do is I'd like you to try finding for triangle HIJ. Again, it's I is the 90-degree angle, J is a 35-degree angle, and they tell us that little h is 10. Solve for the rest of the parts of the triangle. So I'm going to write out here, you want to solve for angle H. You want to solve for, because you know what J is, and you know what I is. I'll have you fill them in also. And you want to solve for side I and side J. Give that a shot, and I'll ask on the form for you to submit your answers. Good luck.